Welcome to this session. This is the continuation of the previous session wherein which we had talked about the database, what is the database management system, what is the abstract model of the database management system with an example. So, in this session let us see the types of databases and the data models we have. So, a wide variety of databases can be identified depending upon the information they contain. Some databases they contain only the text, the strings. Some databases they contain the numeric, textual data as well as the geographical images, then pictures, etc. So, by category or by geographical area or the content that we have in the databases, there are many types of databases we can derive. So, the database categories that we have may be by the subject like the library sciences databases, the computer science databases, the software databases. There are several things that we can have. So, we have to categorize all these databases in under one keyword. On the basis of the content, the database can be categorized as source databases, reference databases and multimedia databases. So, let us see one by one what is the source database, what is the reference database, what it contains and what are multimedia databases, what they contain. Source database, it contains original source data, also called as factual databases. So, they can be one of the following type. Suppose the source databases may contain the textual, then that particular database is called as a textual source database. If they contains the numeric part, they are called as the numeric databases. Suppose if both the textual as well as the numeric are there, then we call them as the textual / numeric source database and then the software database. So, these database originally contains the source data. Then comes the reference databases. These reference databases are nothing but the data that is contained in that database points to some other source database. So, in this particular database we are not at all storing the original data or else not at all storing the source data, however we are storing the pointers. So, these pointers refers to any other source data such as a document or else anything it may be. This may be done by giving cross references or citations or hyperlinks to other sources from a bibliographical entry in the database. So, here we are not at all storing the source data, however, we are storing the hyperlinks to the source data or a citation or a cross reference to other data. For example, these reference databases includes bibliographic databases, referral databases, citation index databases. Let us take an example of any thesis. Bibliographic databases is nothing but at the end of the thesis we write the bibliography wherein which we directly do not put the content inside, however we give a kind of pointer. What is the title of the paper or what is the title of the book, from which press it is been released and then when the what is the volume number or else when it was published. These kinds of things we put up in that particular reference. We are giving a kind of reference, we are not giving the source over there, the complete content over there. We are just giving a pointer that this particular thing I had referred to. Likewise, citation also. Whenever we are writing a thesis or whenever we are writing some sort of paper, we give the name of the name, comma and then we give the year. wherein which that particular citation appears in the bibliography. So, this is also a kind of reference that we are providing. So, whenever we maintain certain kind of databases for these bibliography, referral and citation, then these are called as reference databases. Then comes the multimedia databases. These contain text, images, audio and video. Completely this is a kind of media mixture. You find the textual as well as the images, the audio and the video. The image databases contain the visual information, the textual data contains the textual information. Likewise, the audio data may be containing the audio clips, video data may be containing the video clips. Additional information will also be added with each and every image. Suppose if the image is to be narrated or else a kind of short description needs to be provided. Along with the image, we provide the short description also. The records will be created by keying in, scanning, digitizing or downloading from other databases. So, how we are creating these multimedia databases? Sometimes for the text and other things we key in from the keyboards. Suppose if you want to store the image, we scan the image first of all and then we remove the errors, we remove the unwanted portions, then we save that particular image, or else digitizing an image is possible, or else downloading from other databases. Suppose already there are certain databases already maintained, the same things needs to be replicated. Sometimes we download and we put it in the database that we want. So, this is a kind of various media under one particular umbrella. Then coming to the data models, we have several data models right from 1960s. There are models like a network, hierarchical model and then relational, object oriented model, object relational models are there. So, what exactly is the history behind it? Why they are? Why we want to have a data model? What is a data model? It is a collection of conceptual tools for describing data, data relationships, data semantics and consistency constraints. So, we want to capture the data in one of the model that is there. Suppose if you want to describe the whole data in the form of a hierarchical fashion, then we call it as a hierarchical model. Suppose if we want to make certain relations among the tables, then it is called as the relational model. Suppose if some network thing is being maintained, parent to child and other things, then that comes under the network model. And this data model provides a way to describe the design of a database at the physical, logical as well as the view level. So, this is the basic functionality of the data model. So, whenever we have the analysis done for any company in order to automate their operations and they want to have some backend, then we have to see which data model fits for that particular organization. Then we have to move ahead and we have to describe the data, the relationships between the data, the meaning of that particular data, the constraints that we want to have, the conditions that we have in the terms of that data model that we had selected among the available. So, here is the list of the data models we have. One is the hierarchical model, network model, relational model, the entity relationship model, object oriented data model, semi structured data model. Among the things that are displayed over here, the hierarchical model and the network model are the old models, relational model is moderate, and right now we have object oriented relational models and the semi structured data models right now popularly. So, depending upon the requirements, we have to select the model like the relational model or else object oriented model or semi structured model for that particular organization. Let us see what are the differences between each and every model. Hierarchical data model, this data model organizes data in a tree structure. So, everything we call as a node or else parent and then the child data segment. This is in hierarchy, reverse tree structure. This will be in a hierarchical fashion. This structure implies that a record can have repeating information generally in the child data segments, data in a series of records which have a set of field values attached to it. It collects all the instances of a specific record together as a record type. The complete data is being organized in a hierarchical fashion right from the parent next to the child and other grandchildren. So, let us see one example also. These record types are equivalent of tables in the relational model and with the individual records being the equivalent of rows. To create links between these record types, the hierarchical model uses parent-child relationship. So, suppose if you want to create a kind of relationship between the record types, you can create it through the parent-child relationship. So, these are one-to-one mapping between record types, and then these hierarchical databases were popular in 1960s. So, whenever we had the databases concept in place in 1960s, this model was derived, and this was introduced by IBM in that particular system or project or so. So, the example that we can give over here is the look and feel of the database model will be the parent will be existing on the top as the root and then level 1 child and then the next level children called as the grandchildren. Likewise, from the root till the nodes till level 2, level 3, like the depending upon the requirements, the levels of the children can be defined. This is the overall structure of the hierarchical data model. Let us see as an example. There is a department and this particular department we had identified as a parent in the hierarchical model, and then you have a course and then student, and these are record types, and then in the level 2 you have a professor. So, this is a kind of hierarchical model wherein which right from the root the things are being proceeded at the next levels, children and then grandchildren, or else children at level 1 and children at level 2. So, this kind of representation of a data model is called as the hierarchical data model. It is tree structured. Then comes the network data model. Some data were more naturally modeled with more than one parent per child. In the earlier model, in the hierarchical model, you have one parent and then rest in the next levels you have the children. But here this model is naturally modeled with more than one parent per child. So, this type of representation of a data model is called as the network model. There is a narrow difference between the earlier model and this model, you can observe. There only one parent and then the next level children are allowed. Here this model in a natural way wherein which more than one parent per child is being designed, and this was popular in 1970s. The basic data modeling construct in the network model is the set construct. The set consists of a owner record type, a set name and a member record type. So, these particular three things are available in each and every set. One is the owner, the other is owner record type, other is a set name, and the third one is a member record type. A member record type you can define, it can have that role in more than one set, hence the multiple parent concept is supported. So, one or more for the member record type. A owner record type can also be a member or owner in another set. So, these are the possibilities that we have in the network data model when we compared with the hierarchical data model. The data model is a simple network kind of thing, and link and intersection record types may exist as well as sets between them. The complete network of relationships is represented by several pairwise sets. In each set, some record type is owner and one or more record types are members. So, this thing you have to take care. A record type is owner and one or more record types are members. Usually a set defines one to m, one to many relationship, although one to one relationship is permitted. So, this particular thing completely based upon the network model, and then the mathematically set theory was being adopted here. The example over here we can see the earlier example is being transformed here to two parents. You can see here department student as two parents, and then the rest you can see the course professor. This is how it is been completely transformed from the hierarchical database to the network model. So, coming to the popular data model, which is called as the relational model, which we are using it currently. This uses a collection of tables to represent both data and the relationship among those data. So, whatever we call it as a database, comprising interrelated tables under one umbrella. So, you have the data tables, and then you can find the relationship among the data also. Each and every table here in the relational model has multiple columns, which we can call them as the attributes, and each and every attribute will have a unique name and a data type associated with it. Suppose if an attribute we call it as a student name, we define a data type also associated with the student name, like what it stores, a name of the student. So, a variable character varchar may be selected as a data type. Like age, integer can be selected as the data type for the age. Likewise, you have number of columns, then for each and every column the value as well as with the name along with the data type is defined, and this is completely a record based model. Each and every row of a table is called as a record. Suppose if you have a student record and the description of the columns are, one is student ID, student name, enrollment number, address 1, address 2, and then course. So, these are the column names, or else you can call them the attribute names. Suppose if a student 11 is the enrollment number, and then Rahul is the name, Saket, New Delhi, and then MCA is the course that he wants to do. So, this particular row or else this particular interrelated like data about Rahul is called as a record. Next, another student's name, enrollment number, address can be input. Likewise, for each and every row you call it as a record. Each record type defines a fixed number of fields or attributes. Suppose if the table contains 5 fields or 5 columns, so for each and every field the data pertaining to one student is called as a record. The columns of the table correspond to attributes of the record type. It is mostly used data model all over the world, and there are enhancements for this relational model also. Right now the object oriented concepts are also being embedded in the relational model, wherein which that kind of relational model is called as object oriented relational model systems. So, the inheritance concept, the polymorphism concept, and other concepts from the object oriented programming or object oriented models are being inherited into this relational, and then that model is called as the object oriented relational model, which are very much popular currently. So, this is an example. The earlier example I had taken here, each and every thing is taken as a table. Department is a table wherein which department number, name are the fields. In the professor table you have professor number, name, department number, courses, and then likewise there is a relationship between the department and the professor also. Department number is the common field, just look over there, department number is written over there in the department as well as in the professor field, department number and department number. Likewise for the courses also, course number, department number, professor ID, unit. So these are related, this table, professor table and the course table is related. Likewise student and course is also related. In the student table you will find the fields like student ID, name and then the course. So what course the student has taken, there is a kind of relation existing over here. So these particular 3 data models, earlier hierarchical followed by some network database model and the popular relational database model is there. Apart from these 3, there is another thing called as the entity relationship model. This entity relationship model, we use it for the conceptual design. This actually is a kind of model wherein which the complete perception of the real world of a collection of objects will be transformed in the form of a figure, a kind of entity and their relationships. The collection of object here we call it as an entity. Suppose if the student is there, student we can identify it as an entity. Faculty is an entity. In a university system, faculty is an entity which can be distinguished from other objects. So likewise course can be an identity, course can be an entity. So depending upon the entity and their relationship, we can figuratively draw a entity relationship model. There are symbols associated with the entity relationship model, and using these symbols we can modelize the data. Like this is the example that we have here: book, author, user, publisher, these are the entities. The ones those are shown in the rectangles are the entities. Associated with the book you have several attributes. Book ID is an attribute, book title, book publishing year, ISBN number, pages. So these are the attributes or else the characteristics of the book. Here each and every entity is being identified, and then in the library management system each and every entity is being identified, and then here you can see there is a relationship among some entities, and the relationship between the entities is being identified as either it is a one-to-one relationship, one-to-many relationship or many-to-many relationships, and that kind of type of relationship is nothing but we can call it as the cardinality. So you can read over here, book has author, message user has some messages, likewise user borrows periodicals. So you had taken a real world example and you are identifying the entities, you are identifying the characteristics of each and every entity, and you are trying to map the relation between one entity to the other entity using this ER modeling. So there are fixed number of symbols over here. You can see a diamond is for relation, square or else a rectangle is meant for some identity, some entity, then an oval is for the characteristic, or else you can call it as an attribute for each and every entity. So these are the symbols we were talking about: a oval, a rectangle, diamond, line. These are the symbols that we are seeing in the things. And this is the cardinality that we were talking about: one-to-one cardinality, or else one to n and n to n, many to many. And there are three types of representations. One is the crow's foot ERD. Suppose if you are following this kind of representation of symbols in order to interpret the ER diagram, you call it as the crow's foot ERD, or else there is another thing called as chance form of ERD representation. You can see over here. And then comes the object based data model, wherein which each and everything is being taken as an object, and then the model is been created depending upon the features of the object based models, like the inheritance feature, multi-valued attributes feature, or else inheritance feature, polymorphism features. These features, whenever we try to represent in the object based model, that model is called as the object based data model. Next comes the semi structured data model, wherein which it permits the specification of data where individual data items of the same type may have different sets of attributes. So, at one time it may be having a set of attributes in the at another instance it may be differing with the first set of attributes. So, at that particular instance we cannot go for the standard models like the relational model or the other models. You have to select a semi structured data model wherein which XML is widely used to represent the semi structured data. So, these are the various data models we had discussed about. Before concluding the session, let us sum up. In this session we had seen the data models and then various types of databases. With this we conclude the session. Thank you.